Hi, this is a video for the third part in Labs 3 homework project parts for this jaw. So it might be pretty long, so we'll get started. And the basic idea is extrude, okay? Extrude this piece and extrude the step close to the biting those teeth. Then we make a cut, and something tricky here is this face is tapered down from the body. Okay, the tip is tapered down, and it has a 6-degree taper. Okay, so and it's not at angle that's normal or parallel to X, Y, or Z. It's actually the angle between those two faces, or the intersection between those two faces, are this line at 111 degrees. And so here we're going to use the datum plane to make such a cut at angle from your datum coordinate system or your X, Y, Z. All right, so the main part will be this big sketch. Then the datum, those 2 points, will be a little bit complicated. All right, so hide this, and we'll start from a new file, inch, and I'll just save to desktop. Okay. All right, so again, the sketch XY plane, and we'll start from the origin. It's a circle, and we have a circle that's a 5/16. So 5/16 diameter. Then we have this shape. You can notice we have some fillets because they have the intersection points over there and over there. Then we have a fillet here. Then this looks like an arc, then go straight line, and if you look at this, datum A is perpendicular to this line here, and also parallel to this step, but we're not going to do the step in this sketch. Okay, we'll separate those this piece. All right, so we can use a profile to get the general shape, and from the bottom line here, it looks like this tangent. So we'll turn that into an arc, and it goes up a 1/4 inch, but then a straight line. We'll ignore the fillets. We can do that using edge blend or something else. Then comes up, and again up. So here we're at this point. Make sure this is perpendicular, but it's trying to be perpendicular to that line. So we're just trying to be perpendicular to this line. Then a short straight line. The last one is an arc and not tangent, so we'll just use 3 points. Okay, doesn't matter where, we'll just add dimensions later, and those constraints it's automatically added. You don't want them. Okay, then we're gonna start from this bottom again, and apparently this should be concentric, so we'll find the center point of this arc. That's this point. We'll drag this point, okay, to the sketch origin, or the center of this. So it should give us automatic constraint to make them concentric. Then we'll make this 1/4 inch height, and also the radius is 9/32. then we can use a radius here, just in case it gives us diameter. Then a 1/4 inch. Then we'll go back to inferred. From this point to the bottom is a 1/4 inch. Okay. It looks like we're getting there. Then this intersection point, or this corner point, is 3/8 to the bottom. And I didn't click on the point, so make sure you click on the point, 3/8, and we do have an angle 50 degrees for this line. This straight line to x-axis is 50 degrees. Okay, now that'll probably screw up a lot of things. I'll just drag things back. Okay. Then turn back on our dimension tool. This is 75 degrees. And the next is 6 degrees to the x-axis, or the horizontal axis. Okay, and so the green lines are constrained. So from this point, it's still not constrained. Then this should be on the left side of the y-axis, because that's the distance, 3/64. So I'll turn back on the infer dimension tool. 3/64. Then this line, or the bottom line, is 1 plus 7/32. So we know it's concentric, so this point is on y-axis. If you're not sure, you can just click y, then click this point. That is 1 plus 7/32. Okay, and this point from the y-axis is 1 plus 1/32, and we have the 1/16 is for this line, so we don't have to worry about that just now. Then we don't have any dimension for this point, but we do have a dimension for the rightmost point. So that is 3/8 plus 2. So this point to y-axis, 3/8 plus 2. Okay, you can adjust your sketch a little bit, and we'll add more dimensions. Here to here, horizontal. It's 1/64 plus 1. And we can add some height for those points. So the total height, we can start from the lower one. 11/16. The one in the middle to the bottom, 15/16. Then the top one to the bottom is 1 plus. So 1 plus 7/64. Okay, as you can see, the color, the top is green. Right, then we'll deal with this arc. So all you need is really the radius, 2.5. So once you have this 2.5, it should be all constrained. Okay. So if you would like to, you can have multiple loops in single sketch. For a better management, you can finish the sketch and start another one. Or if you want to see 3D things, you can make an extrude now. It's not, you can make it multiple ways. So we are doing a second sketch on top of the first sketch for this little step here. Okay, and since this one is the same line, I can project this line into our sketch. So the blue lines you see now is from sketch 1, and I'll project a single curve, okay, from the first sketch, and that's the line we just projected. And actually we do need some, we missed the one line in the first sketch. We missed this line here. This is a reference line, but we will have to need this for this angle here, okay, the taper. So 111 degrees. Okay, we can overshoot this and trim this off. Then to reference and dimension it. The bottom point to y-axis is 1 plus 1 over 32, and we have an angle here is 1, 1. Okay, that's constraint. And the second sketch, we have this line here. We probably need to project this as well. So we'll do a project curve for single curve again, and that's a reference curve. So maybe it's better to put this sketch into the first sketch. Alright, so I'll draw everything in the first sketch then. So 3 lines, 1, 2, 3, right? Rather 4. So we have something starting from here. It's trying to get perpendicular, but we can just ignore that. And here you do want perpendicular. If it's not there, you can always add that back by selecting both and apply the constraint. You can tell from this parallel to datum A. Okay, datum A is perpendicular to this top line here, so they should be perpendicular. I mean to the top line. Then we'll add dimensions, and we have the starting point. This starting point is 1/16 away from the corner here. So from here to here is 1/16. Then that's 3/16 for the arc, so we'll do that later. And this angle is 85. Okay, and how much we don't know, but if you look at another view, okay, we have a 1/2 inch. So a 1/2 inch is from this point. Okay, that's actually the length of this, the horizontal length in this view, 1/2 inch, and also this should be 1/2 inch. Okay, and you can drag things around a little bit. Alright, so when you're looking at the drawing, you need to look at multiple views to get the dimensions. Okay, anyway, 135 degrees, so between these two are 135. I think we're getting there. We at this very end we have 2 dimensions. 3/64 is this length of this one, and also the distance between this line to datum A is 1/16. Okay, as you can see, it's all green, all constrained. Then might as well just add the arc into this complicated sketch. So we have a 1/4 inch from the top, from this point here. Be sure to snap to that point. This is a 1/4 inch, and at this point it's 3/16/4, 3/16. Then we have a radius of 0.6. Once you add this radius, it'll constrain the geometry. Alright, so let's check. So we should have all the dimensions, and it's getting really slow on my computer. We have all the dimensions, everything's constrained. Okay, so we're good to extrude. Then since we have all the loops in one constraint, it'll be funny to extrude. So extrude and a region boundary curve. We want to extrude this region. We can actually just extrude this one first. So this one should be 9/16. So symmetric. So 9/32. Apply. Then the higher the little step close to the teeth is this region, and we can take a look how much this is. 3/4 divided by 2, 3/8, and we don't do a unite here. Okay, so the reason being is we need to cut that later, and that's two different cuts. If you unite them, you will not be able to make the lower cut 6-degree angle, the tapered head. Okay, so don't unite them. And it looks sharp here. You can do an edge blend. So 1/16 for this. Apply. Then we have a 1/4 inch radius for this one. Okay, then we'll make the cut 6 degrees, and as you can see, section BB is not a X, Y, or Z plane. It's perpendicular to this, or it's normal to this line, reference line here. So what we need to do is we need to build a datum plane, and you can use inferred, it'll recognize that. And the exact method is on curve. Okay, so on this curve, well, it's not picking up. I'll just do invert. Interesting. So on curve, it will not pick up that. Okay, we'll do invert and then pick this point. Make sure the point is, make sure this reference line will highlight, and it knows you want to have a data that's normal to this reference line, and the arrow indicates the normal direction of your data. So use right hand rule. If you do this now, you will have a sketch look like this from this direction. So if you want to look from this direction, you can reverse the normal. It's just a little thing, it doesn't really matter. You can always draw, reversely. So we'll pick this datum for a new sketch to make that 6-degree cut. Finish. And apparently my coordinate system is over there, projected from the origin. So we'll just leave it like this. And now your F8 will not work, will not go back to the sketch. So you can do right click and orient your view to sketch. Okay. Alright, now we do 2 cuts. Let me call this back. So one is from the top, make it taper 6 degrees. Okay. The other one is from somewhere here, also 6 degrees. and it's better to look through it. Okay. And the other cut, you want to snap to the top. So let's see if we can snap. So you want a point on the top edge, something like this, point on curve. Okay, then the same degree, so you can use parallel. It'll automatically add parallel. Okay, and exactly where left and right this point is, it should be aligned with this point at the bottom, right? So what we can do is we can start a vertical line from this reference line, then turn that to reference. Okay, so this is a reference. We can add another constraint for this point and this line. So this 6-degree taper will start from the projection of this reference line from the first sketch, and also on the edge of the surface, on the edge of your extrude. And now we can add the angle here. It's from here to x-axis is 6 degrees. Since they're parallel, we just need a 1. And in the 3 constraints, that's the length of this line, this line, this line. So it doesn't matter as long as this is longer than your parts. But in case you want to change the design, you can, add some other parameters. But I'm not going to do this. So we can make a closed loop for those lines. This way, you can use extrude and make a cut. Alright, the other way is you can just extrude a single open line, use trim body, but that'll leave a sheet body over there. Anyway, so finished sketch, we have 2 closed loops, or well, that'll have 1, 2, 3, multiple regions. Just make sure you know which one you're extruding. So we'll extrude this. Okay, we'll cut the top first and pick this as well into reverse the direction. Make this solid, cut into the top. Okay, and so here we'll use subtract. Which one? This one. And apply. That's the taper, and then we need to extrude the lower one. Then cut into the body. Here we'll just pull the arrow and take a look. So if you look from the side, the top has been tapered. And what about the bottom? We can do a mirror feature. So we can insert associative copy and mirror feature. What we need is those 2 extrudes. So we'll select those 2 from the tree. You might need to hold down Shift key here when you select them. Then the symmetry plane of the mirror plane is XY plane. So let's see what we have here. We have a ZC. That is a normal for XY plane. So you can just pick this one. And look at what happens if I click OK. So that's the bottom, and this is symmetric. And the head is tapered. Okay. And the last thing is cut the inside, so this can go onto the handle. So the inside sketch, it's an extrude and a subtract, right? And now we need to make another sketch. We'll hide this, it's not necessary. And we can probably, we can unite these two pieces now, because we have already done the cut. Okay, so they are united. Then make another sketch on XY plane. Then all we need is really just this line, because we're going to use this line to make this profile. Then all these things on the left side, we just cut them off. So what we do is hide the solid first. So we need the profile from the first sketch, or maybe not. We can draw a whole circle, and the radius or the diameter is 9/8, and we have vertical and horizontal distance. So horizontal 1 plus 5/8, vertical distance 3/8, and that is constrained. Then we have a line coming down from here, intersects with this, and looks like this should be going through the center of that arc, or should be perpendicular to this arc. Okay, so we'll just go a straight line coming down here, and it's trying to get a tangent. Let's go back. Alright, just ignore that. Alright, so move it here when you see a perpendicular to the arc. Okay, so that'll give us this perpendicular constraint. And then we can take care of the tangent constraint, just delete that. Then we can move this thing around. You keep perpendicular to the arc. Then we have this distance from y-axis to this intersection point. So click Y and click that point, 1.3, and that is constrained. So we have this profile, it's done, and what we need is to close this loop, and it's giving me that tangent again. I'll just do it from the bottom, and I can overshoot. Okay, and to look better, I'll just trim them. Close, and that is my sketch in the middle. And we'll extrude this region into a cut that is a 1/4 inch thick in the middle. So symmetric, 1/8 for a half, divided by 8, and this should be subtracting, show the solid, subtract this solid, and say okay. That this way we have this slot in the middle. So we're pretty much done, except the chamfer here, 0.5, 45 degrees. Usually we ignore those cosmetic things like chamfer, edge blend, but this is pretty big chamfer, so 0.05. Okay, for the top and for the bottom. And it doesn't really like it because it says the geometry is not simple. So if you don't like this escalation mark, you can go into setting and change this to offset, face, and trim, which this says here, and it'll take care of that. Okay, so that's the part, and then we can hide all the sketches. Alright, so for the teeth, it's pretty much the same as the other part. Just make one and go pattern the feature. You can use this pattern feature. We have along the line, so you can make one, extrude and cut, or extrude and subtract, and along this edge. Okay, then you can also along those edges. So that's pretty simple, and this will be the end of this video. Okay, thank you.